ESI would like to share with you our automated assembly planning prototype. This is the outcome of a research project between ESI North America and Oregon State University in conjunction with the DMDII. Starting with the import of CAD data, the user can define the parts and components of the subassembly and assembly to be included in the automated planning sequence. The user can also define at this time a reference part, a stationary component to which the other components are to be assembled. To start the automated assembly process, the user is guided through the operation with a wizard that gives them the individual steps to proceed through the process. The system determines, if possible, the constraints and prompts the user if more information is necessary. For instance, if the geometry alone cannot provide sufficient information to determine the assembly sequence. The user can then at this time also specify additional constraints, for instance, if there is a particular installation direction that the user prefers. Once the constraints are determined, an assembly plan is automatically generated. This is similar to the way your navigation system can plan routes between your house and the airport. The system is comparing the vast number of possible sequences to propose the best way to assemble this rear axle. Once the automated assembly process is computed, the best assembly sequence is defined and animated. The sequence can be played back to see how the rear axle is being assembled. The assembly sequence shown can be a single path, as shown in this video, following a linear sequence, or it could be multiple assemblies performed simultaneously. Automated assembly planning can also consider if rotations are necessary to achieve the process. For example, if there were subassembly operations where flipping the parts over were necessary and helpful. If the user determines there is something undesirable about the proposed sequence, they have the ability to edit attributes such as the stability or the use of collision rules and have the system recompute the assembly plan. Here we can see that when considering dynamic collisions, the assembly sequence would be modified. Once the assembly sequence is complete, we note that the reference part and the mounted components are treated as a unit during further simulated interactions. That concludes our review of the Automated Assembly Planning Project between ESI North America, Oregon State University, and the DMDII, combining artificial intelligence, virtual reality, geometric reasoning, and a user interface to automatically generate assembly sequences to provide a powerful tool to streamline assembly planning.